Hey, welcome to Organic Chemistry. Today we're going to be talking about bond line drawings, and in organic chemistry, in order for you to be able to figure out what the molecular formula of a carbon-containing compound is, you would have to be able to read these structures or get used to them. So first of all, we're going to start off with how to count the number of carbons in a structure, so that way you would be able to write down what the formula will be, and we're going to get to that as well as naming later. But first, if you look at the structure right here and ignore my numbers, you can start anywhere. And like I said, we're going to get to naming, but here you can start counting at any endpoint or corner. You can pick one, it doesn't matter. So first, if I were to start here, you can count 1, 2, 3, 4, 5, 6, 7. Or if you were to start right here instead, you would still get the same number of carbons, the same total amount. So it's going to be 1, 2, 3, 4, 5, 6, 7. And so if we were to move on to the second structure, let me write down right here, the number of carbon equals 7. So right here, if you were to count, it's going to be 1, 2, 3, 4, 5, 6. So this one would have 6. Let me number it. 1, 2, 3, 4, 5. Again, you can start anywhere. And then here, we're going to count 1, 2, 3, 4, 5, 6. Remember that there are 2 carbons here because this is a triple bond. So you have 1 carbon here and then 1 carbon here. And then if you were to move on to this one, as you can see, like I drew it out for you. So you can see that this is going to be your carbon 1, carbon 2, carbon 3, carbon 4. And here is your triple bond in the middle of the 2 carbons. And then 5, 6. So the total number of carbons would still be 6 for this structure. And here, it's a ring, so you can just count as how you normally would. So it's going to be 1, 2, 3, 4, 5, 6. So you have 6 carbons here. And here, you can count, start here, 1, 2, 3, 4, 5 carbons. Or if you were to start here, you're still going to get the same number of carbons. So let's see, 1, 2, 3, 4, 5. And then this structure, you are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, if you have a double bond, you can like keep counting as usual. But if you were to have a triple bond, like right here, we have 1 here, 1 down here, 1 up here, and then the 1 in the middle, then you would have to take into account the 2 carbon here. So then in that case, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Continue on this one. You're going to have 1, 2, 3, 4, 5, and then 6 here at the end. And then this one, you're going to have 1, 2, 3, 4, here, 5, here, 6, and then 7 here at the end. That's attached to nitrogen right here. 7. So you have 1, 2, 3, 4, 5, 6, 7. So at each endpoint, or you can say corner. And then our last structure, we have 1, 2, 3, 4, 5, 6, 7, 8. So let me number it. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so it doesn't matter the order that you count your carbons in this case. So you can just start anywhere and then keep counting. And once you get to naming, that's when you start to pay attention to the order in which you count your carbons. But right now, you can start anywhere. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 right here. All right. So now we're going to move on to some more examples up here. So there you go, your molecular formulas for some compounds. And you have your Lewis structures, your condensed, and your line angles like we just talked about. So if you were to have a CH3H7Br and are asked to draw your Lewis structure, this is what it would look like. As you can see, you would have your carbon with your 3 hydrogen here for C3. So you have, first you have to count the number of carbons first to make sure that your chain has the correct number of carbons. So if you see C3, you would have to double check with your Lewis structure to see if you're asked to draw one, to make sure that you also have the same amount of carbons as the one in your molecular formula. So here, C3, we're gonna have 1, 2, 3. And then we're going to move on to H7. So as a whole, we have 1, 2, 3, 4, 5, 6, 7. 7 hydrogens here and 1 Br. So if you were to condense the entire thing down, it would look like this. So you have CH3, CH, Br here, and then another CH3 at the end. And if you were to draw your line angle structure, it would look like this, like we talked about before. So you first would have to double check your number of carbons to make sure that you have the correct number, the correct amount of carbons. So you have 1, 2, 3. So that's 3. And you know that the Br, the bromine, is attached to your second carbon, which is right here in this structure. And the number of hydrogens will be hidden, so that means that you would assume that the hydrogens they're not drawn out, and so you would have to also take account for those. So in this case, we have a carbon here, and you know that carbon has 4 bonds, so that means that the 3 other bonds will be your hydrogen. So 1, 2, 3, and then 4 with carbon right here. And then same thing here, we have another carbon here. So this carbon also has 3 bonds, so 1, 2, 3. So it's missing 1 more bond, which is the hydrogen that's not drawn out here. And then we have 1 right here. We have 1 bond to C already, so we know that there are 3 others that are not drawn out, which are hydrogen. And you can draw them out like this, like that. And then you would have your structure. Move on to the next one. We have C4H10O. So we're gonna have 4 carbons. 1, 2, 3, 4. we're gonna have 10 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then your condensed formula would look like this, where you would have CH3 and then CH2, but 3 times. So you have 1 CH2, 2 CH2, 3 CH2, and the OH at the end. And then if you have to draw your line angle, it would look like this, where you would have 1, 2, 3, 4 carbons, like here, your molecular formula right here. And then you can start drawing in your hydrogens to make sure that you also have the correct amount of hydrogens. So if I were to draw this out, you would have 1 hydrogen here, 1 here, 1 here, because you have a carbon right here and it has 4 bonds. So the other 3 bonds will be to your hydrogen. So 1, 2, 3, and then 4, 5 here, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 here. So this is so you know that you have the correct structure. And then one last one, you have C8H14. So in this case, you're gonna have a ring for your Lewis structure, where you would check to see if you have the correct amount of carbons again. So it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, so C8, and then H14. So it's basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then your condensed formula, you're gonna take a look at this first, your ring over here first, because it's a ring. You can see that we have 1, 2, 3, 4, 5 carbons in a ring, and 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogens right here. So C5H9, that's your ring, so that's taken care of, and you can move on to the next C carbon. Here you have one CH2 here, and then another CH, and then another CH2 right here. So if you were to draw and again, this is the same thing, you can write CH2 like this, or you can put your double bond in so it's easier to see. And then your line angle structure, we're gonna make sure that you have 5 carbons for your ring, which is 1, 2, 3, 4, 5, like that. And then you have 3 other carbons that are also attached to this carbon attached to this carbon right here. So, but outside of your ring, you would have 3. So 1, 2, 3. So for the ring, we have again 1, 2, 3, 4, 5, and we also have 6, 7, 8. So again, C8H14. As a whole, you have 8 carbons. So here you can see that the double bond is right here. So if you were to put in your hydrogens, you would be able to see it easier, like better. So first, this is your C right here. I'm gonna draw out all the C's so you can see it. Here we have 2 bonds connected to C. So C already has 2 bonds here, so we need 2 more to make 4 again. Same thing here. You can keep drawing your hydrogens out so it's easier for you to see. This C right here, the C already has 1, 2, 3 bonds. So we only need 1 more hydrogen to make 4. The C right here, we have 1, 2. So we're gonna draw 1, 2 other hydrogens here. And then this C right here, we have 1, 2, 3 bonds. So we know that we need 1 more hydrogen here. And then this C here, we have 1, 2, and then so we need 2 more to make 4. So again, you can double check by recounting all your carbons and hydrogen. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. So C8 and then H14. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then you're good. All right. Hope to see you guys later.